Hey class, uh, bad news. The second midterm didn't go so great. Uh, we'll talk more about this on Wednesday, but I wanted to take a moment to show you how you could do the free response problem without actually doing the free response problem. Uh, and we'll have a quiz on that on Wednesday. I know I said there wouldn't be a quiz this Wednesday, but I'm actually going to change that. I'll send that out in an email with a link to this video after I upload it. But we're going to have a quiz. So let's talk about how we can do this problem. So I knew this wasn't going so great during the exam itself because I saw all of the blank stares. I saw people stressing out when they got to the free response problem. And I know that it might seem a little bit more challenging because I did a weak base for our buffer, but really the problem is exactly the same. And I wanted to show you some tricks, some thought processes you could use to do the problem without actually doing the problem. So let's go ahead and look at this. So this is a buffer prepared from 0.4 molar stock solution. And we want to make 250 milliliters. A 0.2 molarity. 0.4 molar stock with 1 molar HCl. Now, without actually doing the problem, let's just think about the problem. So we know that this is a buffer. We know that this is going to be done kind of like a titration because we're starting with stock solution and we're adding acid. This is a weak base. So without doing the problem, we can just think about the parts of the problem we can do. And the thing that I really wanted to interrupt the test to say, and even a few students asked questions, and I was like, write down what you can do, write down what you do know, because we can think about this and get around the problem. So we know that the curve is going to look something like this. We know that the buffer range, buffer capacity, buffer region is there. We know the midpoint's there. We know the equivalence point's there. We have target pH with 1 molar HCl at 0.2 molar and pH equals 7.25. pKa is equal to 7.43, given to you as pKa. So we know that the pH right here, 7.43. So right away, we can tell that our buffer is going to be someplace in this area, right? Our buffer is going to be there. So if we knew perhaps this range of volumes, we could ballpark the answer without actually having to calculate the answer. So let's calculate the volume to the midpoint and the equivalence point, knowing that if we made this buffer correct, this would be 0.2 molarity all weak base. This would be 0.1 molarity weak base. And this would be 0.1 molarity protonated base. And then this would be 0.2 molarity, approximately. We'd have to take dilution into account. 0.2 molarity protonated base, right? If we made our buffer. So we can do our calculation for the equivalence point just by doing 0.2 molarity times 250 is equal to 1 molar times our volume of HCl. Notice, I don't know how much of my stock solution I need to make this buffer. I'm just saying how much HCl would I need for my titration, pretending like I couldn't figure out the problem. So I'm going to go ahead and do 0.2 times 250 divided by 1. My volume of HCl, in that case, if I do 0.2 times 250, that's going to be 50 milliliters. That also tells me the volume of HCl to the midpoint going to be 25 milliliters. So, without understanding buffers per se, but just understanding a titration, I can say that I'm going to need approximately, let's just pick halfway between 50 and 25, let's say 33 milliliters of HCl. Approximately, right? We're going someplace, maybe a little bit less because 7.25 is pretty close to 7.43, so maybe 30 milliliters, maybe 29 milliliters, but we're in the right ballpark. And we can show that we logically understand the process of how to think about this, even if we can't do the buffer calculation. Now, we can do a similar calculation to this to figure out how much stock solution we need. Because we know we want this concentration at the start, so I can do 0.2 times 250 is going to equal 0.4 times the volume of stock. And that's going to give me, divide by 0.4, that's going to give me half of 250, so that's going to be 125 milliliters equals the volume of stock. Even if we couldn't remember the calculation we did on the homework, even if we couldn't remember the calculation we did in lab, even if we couldn't remember the calculation on the quiz, or on the buffers worksheet that I also handed out, we could still just use our knowledge about the titration curve to get past that and show that we still understand something about the problem. And it turns out this answer is actually pretty close to the right answer. It's not exactly the right answer, but notice, really the point is it shows that you have some understanding and you can think about it. That's for part A. Let's go ahead and look at part B as well. We can essentially erase this and do part B, right? I want to leave, well, maybe I should have left that. But for part B, it wanted to calculate buffer capacity. I'm going to put this back up. Whoa, weird looking 5. So, if we want to understand buffer capacity, most of you put the buffer range, right? And we can say the buffer range is going to be from the pKa, it's going to be 6.43 to 8.43. But that really doesn't do anything to tell us about the capacity. The range is all about the identity of the acid. The capacity is all about the stoichiometry of the problem. Some of you, I would say about 7 of you, so maybe 1 lab class worth, like there's a group of you that said, if you just calculate the equivalence point, 50 milliliters, close enough. That's not actually true, because if you go to 50 milliliters, you're way outside of your buffer range. If you were trying to protect a system, your system is ruined. If this was a physiological system, all of the cultures, all of the cells, anything you were trying to protect are all dead. If this is, it just wouldn't work if you said 50 mils. What we could think about to kind of get to that approximation, again, if we're like, okay, I can't remember how to do capacity at all. Even though it's really just find the volume to this, find the volume to this. So find the volume to there, find the volume to there, using the Henderson-Hasselbalch equation. But let's say we couldn't remember that. We know it's going to be a little bit less there and a little bit less there. So if this is 100%, let's say it's 90% and 10%, and we could say the capacity is approximately 8/10 of the equivalence. Now, this is a very rough approximation, right? 8/10 I'm saying, because all the way from the beginning to the equivalence point would be 100%, and I'm saying I want to bring that in a little bit from each side, like 10% there, 10% there. Very, very rough approximation, but again, the point is it shows that you understand that the capacity is related to the range, the capacity is related to the stoichiometry, and then you would say 8/10 or 4/5 of 8/10 of 50 milliliters is approximately 40 milliliters. And again, that's not the exact right answer, but that's pretty close to the right answer. It demonstrates understanding, but really in order to do this correctly, you need to know how to use the Henderson-Hasselbalch equation with the stoichiometry. So you need, for getting the creation of the buffer correctly and getting the range correct, or sorry, the capacity correct, you need to have pH equals pKa plus log B over BH plus. And notice, because I'm using pKa here, it is still conjugate base over weak acid. If we're using the pKb equation, which I encourage you not to use, you have to flip some things. But since we're in the buffer range, we can use pKa and we can do conjugate base over weak acid still. We can calculate this ratio. We can use the definition of the total concentration for part A, or we can plug in the two different values here for part B, realizing that we have to solve for some volume of acid that we're adding. We can do all of that. You also, if you're going to do part C, you have to use the Henderson-Hasselbalch equation and the stoichiometry correctly. There will be a quiz on this, with me expecting you to actually be able to do these calculations completely, not just the approximations, on Wednesday. So I'll mention that in email as well, and I'll encourage you to watch this video so you can get some ideas about how to think about the problem in a simple way. And if you want to see how to do this calculation correctly, look back, I think it's the week 4 video or maybe the week 5 video where I actually go through these calculations as well. Or come to office hours on Wednesday and ask me about it again. I'm happy to do it again, but I can't spend more time on class in it because we have to keep moving forward. So I hope that's helpful. We'll talk more about what we're going to do about the midterm average on Wednesday in class. Thanks.